a few days ago I published this circuit, a demonstration of how to test an infrared sensor. And after that I published another video talking about again the different frequencies of light in the nanometer range. And here you can see more or less the colors. I've talked about that. There is in fact no real definition for what red is in scientific terms. That's what I mean. Same for the other colors, etc., etc. But we know, of course, the spectrum in the nanometer range. Want to refer to my earlier videos, and well, there in those earlier videos there was much more information in the text box. Also showed this, the spectrum of a white LED, light emitting diode, compared to say daylight. With daylight we see a very big peak here, etc., etc. Want to refer to the earlier video, and told of course that only the spectrophotometer can give you precise results when you shine on that spectrophotometer a LED shining out light, visible or invisible, and then you can exactly study the spectrum. I found during these experiments that when you lift up the voltage to a light emitting diode, the spectrum also changes. That's quite logical. When we look at the theory around how a light emitting diode works, etc., etc. Well, the thing that I wanted to show is this schematic. I wanted to make, say, a kind of apparatus, a tool with which I can test light sensitive units. Could be for visible light, for instance this visible light, or invisible light. Here is an invisible light sensor, an IR sensor for the infrared range. And my idea was to connect all these LEDs with a switch to a multivibrator, so let them flicker in a certain frequency, and then with the help of your oscilloscope you can see sometimes, that depends a little bit on how the circuit is made, but you can make, say, the flickering of that light in all these, say, colors visible. Important is that the resistor to all these LEDs differs. Has everything to do with, say, the exact voltage that such a LED needs to work properly, say, to give us out a certain amount of light. That differs. And why does that differ? There are many reasons for that, how that a light emitting diode is made, for what current it is made, etc., etc. The voltages, by the way, are more or less fixed for all these LEDs, and that has everything to do with the barrier voltage on the diode, and that barrier voltage is directly related to the color. So, pen over somewhat. Want to show what I've made. This is what I've made. Very simple unit. Here is a multivibrator that does the job. It makes that the LED flickers, and here I can choose between all these different LEDs. Infrared, red, orange, yellow, green, etc., etc. And here is that bunch of LEDs. Perhaps they need a reflector, I have to study that better, but anyway. So all these LEDs can be switched on and off. Say that they flicker or not on a certain nanometer frequency. Want to tell more about that? Like I told, the resistors here are different. Depends on the LED that you use, and here is a table of the used resistors. That must be tested out in practice, of course. So not always a white LED works good at 200 ohms at 9 volts. That's the supply voltage, 9 volt here. But you can easily find that out. Very easy. And of course it's important that the LEDs stray out approximately the same amount of light. Schematic again. When you change the value of this capacitor, the frequency goes up. With that 560 nanofarad capacitor switched in, so 0.56 microfarad, we are in the 70 Hertz range or the 100 Hertz range. So let's see what this circuit can bring. Here is again that infrared sensor. I'm now going to stray energy into that infrared sensor via the infrared LED, and that's here. It's the kind of purple LED here. And this is the frequency of the oscillator, the multivibrator. Like I told, you can change the waveform by changing the value of this capacitor. Anyway, it works around 107 Hertz. It's clear to see. And I have connected my oscilloscope to this infrared sensor. So now I'm going to shine light out of this bulb of LEDs, but only the infrared LED works. So I now shine that light on the infrared sensor, and we can see on the oscilloscope how that works out. So you see directly that the sensor receives the frequency of approximately, well, what is it? A high frequency. That's all I can tell, a high frequency. That means that it works. Thanks for watching. I am now, I receive a telephone. Thanks for watching.